You're welcome.
Okay.
Do you want to be recording every morning?
Anything like this, yes, by default. Not every morning though. Sometimes we don't need to. Otherwise, I just put it on by default. Okay. So let's stretch your minds a little bit. Why even think about using encapsulation? How does this help us? Back to you, Kosi. You got more answers than you.
Try. So I think going back to the concept of I suppose being able to hide the data that needs to be hidden. So just to be able to extract the most useful data, like the most appropriate time. It just helps with extracting the most useful information from the right methods. Something along those lines maybe.
Extracting the most useful data from methods. Okay, let's build on this. Bridget, why use encapsulation?
I would say hide certain variables so it cannot be changed or accessed.
Okay, so there's something here about the stability of a program that I'm hearing, where you said something along the lines of if something can't be changed, because it's not accessible. So the link I'm drawing here is if it can't be changed because it's not accessible, it means it's unlikely to cause any instability in your program. All right, any unexpected changes, any unexpected modifications. Big so we can see this. So that's actually a good thing. The more changes within a program, so the more you change one variable, and the more likely it is you'll introduce bugs. So if things don't change, then you know it's stable and you can rely on those values. So if something can't be changed because it's not accessible, this is usually a good thing because it increases stability. So that's one part. If we're thinking about part two of our definition here, what's public and what's private. Let's keep going. See any other questions at the moment? Ben, what about you? Why using encapsulation?
Would it make like code a bit easier to read and understand if you kind of group in the similar behaviors together?
Cool. Easier to read and understand. Yep. I mean the little processor chip doesn't care about what files or where's the data, doesn't even have any concept of a file when it actually executes your program. So encapsulation is entirely for our benefit, right? As people who maintain and extend code. Cool. Okay, so let's we might come back to this at the end to sort of see how our understanding of encapsulation has changed or sort of deepened. But here's like perhaps a visual representation of encapsulation. I'm not sure whether this might work, but what you're looking at here is a lovely mess of a diagram. All right, you can see here arrows, red and blue arrows leading from circles, and this is an unencapsulated program or a diagram of one. Where blue, the blue lines indicate the code path of possible code paths of this program, and red is the variables that are set and how they can be accessed at different parts of the program. And as you can see, it's all just kind of a mess within the same scope. You can kind of access any of the variables all over the place. So this is taken from a real snippet of code, just trying to work through the code parts of this program and the state of the program, state and behavior. So blue is the behavior, red is the state. There's another version of this when it was better encapsulated, and it'd be interesting to hear some of your thoughts about the difference between them. So here it is unencapsulated, and here it is encapsulated. What do you notice as the difference between them? Just have a quick look. I'll keep scanning between them. Again, we're not going to worry about the code for the moment. Just think about the visual diagram that represents this code, where blue is the code paths, and that travel throughout the program, and the red is the state that's available. You can have a look at the better encapsulated version. What do you notice?
It's more organized.
All right, it's more organized. Yes, good. What signals did you pick up on that?
I can't really see it properly because the font's quite tiny. But
So how did you know it was more organized? What visual signals did you get?
Things are more grouped.
Things are more grouped. Okay, things are more grouped. I like that.
Yeah, so this one is just like everything under one big umbrella. So you can't really pinpoint stuff and where they belong. But with the other one, you can kind of trace things back to, like, should I say, a group or...
Yep. And imagine if you wanted to go change something in your program, and so they've encapsulated some of the code under this specific object called a random word printer, whatever it is. And I know that this is all I have to deal with when I have to go change something or add it in. I don't have to worry about anything else in my program. This is all the stuff that's inside of my random word printer. All right. Whereas if I have to do the same thing over here, I'm already overwhelmed. Right? The cognitive load of trying to understand this program is huge, to be able to change any one part of it, or to understand how it works. Whereas this one, a little bit easier. All right, I can go to different parts of my program. On the left-hand side, there's probably still more work to be done here. All right, it's probably not entirely finished in terms of this encapsulation process. But at least it's hidden under perm printer, so it's separated from the rest of it, and I have got some clear objects with their own state and behavior. Notice also the red lines are a lot less, or a lot fewer. All right, so we're trying to put state where it should be and keep it minimal. So on the right-hand side, there's only a couple bits of red arrows that we need, whereas on the left, there's still probably a little bit more work to be done. So we're trying to move from programs that look like this, or even parts of our program that looks like this, to things that look better with, sorry, when I zoom in, it doesn't scroll better, to programs that look like this. All right, so a visual diagram of the process of trying to better encapsulate, thinking about the state and behavior that's available. So we're using classes. So let's have a look at our session. Our objectives for the session is to be able to define behavior as the thing or things a program does. Explain that a class is a convenient encapsulation or a convenient vehicle of encapsulation of behavior. And then we're actually going to try and do some very simple examples, small examples, but encapsulate program behavior into cohesive classes. So cohesion works hand in hand with this idea of encapsulation. Cohesion is simply a measure, mostly subjective, all right? A subjective measure of how relatable or how similar the behavior is inside of a class. So always think about low coupling and high cohesion. You want all your classes to be highly cohesive, but also decoupled from other dependencies. A class has high cohesion when anything inside of it, everything relates to that purpose, without anything else extraneous. So let's have a look at this example. Again, quite simple, quite contrived. But we have a class called square. It's got a constructor function that we can use to create squares of varying length. We've got two functions, perimeter and area, that manipulate that property, multiplied by 4 or raise it to the power of 2. We've got a summary method that logs a bunch of data about the class. And then we have a method called say hi to Ed, which console logs hi Ed. So if you wanted to group these methods by how related they seemed, one way you could do it is to try and plot them in terms of relatability. Entirely arbitrary, you might put them anywhere, but in order to just think about how related they are, here's like one way you can visualize the methods. You might think, say hi to Ed has got nothing to do with the rest of them, and you probably would be right. So let's put this on like one edge of our map. These ones seem a little bit more related to each other. All right. This is helping perhaps think about which methods seem to be related. And we got some information about how related they are from the method name, what we call the method signature. All right, the method signature is the method name, the arguments it takes, and any other information about it, but not to do with the method body. All right, just the method signature is this line here. So we got some information about the method signature to say, okay, it doesn't seem to be that related to anything else inside of this class. So arguably, at this point here, we would say, okay, it shouldn't belong in this class. It reduces this class's cohesion, and we want to always find ways to increase it. So let's find a way to take it out of this class and move it somewhere else. So we could regroup it quite fairly trivially to a separate class. We'd end up with 2 classes. All right. So we've moved one method from class square and created another class for it. Now, this is quite a simple example, and arguably, how would this could even be made even more cohesive if you wanted to be a perfectionist. There's a bunch of console.log statements in here that don't need to be in this class. It's not the class's responsibility to log to the console. But let's leave it there for the moment. So we've gone through one process where we've identified a method that doesn't seem to belong in it. We had a quick sort of a diagram to sort of look at the relatability, how related they are, and we've moved it into its own class. So I want you to jump onto the mirror board and draw up some quick diagrams of these 2 examples. Here are your methods. And do a quick, no more than like 5 minutes, shouldn't take that long, to draw out some axes or however you want to. And what do you think is, how do they relate to each other? On some kind of diagram that looks like this. All the information you have to go on is the method signature, all right? You have nothing, you have no clue about the actual method body, and it should just be an instinctive reaction about looking at the method names, what feels like it's more related to each other. So jump onto the mirror board. There's a huge board here, so try and make it small so everyone can fit on it. Find out any space and just write some quick diagrams, draw some quick diagrams about how related you think these 2 sets of methods are. The class at the top, bank, and these are the methods inside of it, and the same with secret diary. Shouldn't take you more than 5 minutes. Just another couple of minutes. I like someone's little area, they labeled it mine. Everyone's dexterity using Miro is increasing, which is very good to see.
Yeah, sorry, Ed, I don't really know what I'm doing here. I'm trying to associate various methods with the class.
Yeah, well, it's probably a lot more simple than you think.
I mean, as in so get balance credit account, those are obviously to do with bank.
Mhm.
The other ones are to do with secret diary. What more can I add to that? I mean,
So there are two separate examples. All I want you to think about is, out of these 4 methods for bank, which ones feel more related to each other than not? So if you have to arrange these 4 methods on some kind of diagram that shows how related they are, how is get balance related to credit account, debit account, print statement, and organize them accordingly, you might end up with some version of this.
okay, so which ones are more related to each other and which ones are less related to the other 4 of them?
Exactly.
Or other 3?
Yeah, exactly.
Okay. All right, thanks.
It's it's a simple task. I think probably most of you will get more practice actually using Miro than thinking about this diagram. But it's a good place to start. Okay, if you finished exercise 1, jump into exercise 2. Same thing, but now you have a little bit more information about your class, not just the method name, but also the return values. So no more than another minute or 2 for exercise 2. Use a diagram to group the methods in this example. So your calculator is your class, and you have 3 methods: add, subtract, and print. Again, these are quite simple classes, quite simple things to have a think about. go over a couple of them quickly in about a minute's time, all right? Cool. All right. So we should have got to the end of exercise 2. Give me another 30 seconds to wrap that up. We should have 3 diagrams, one for bank, one for secret diary, one for calculator, and some kind of diagram that shows how related you think those methods are to each other. Okay, so let's have a look at this profusion of diagrams. Okay, I'm not going to scroll too far to the edges. Let's just go to this one here. So we've got three boxes if you're looking at my screen. This looks like it's for the calculator example. And it looks like add and subtract are more related to each other than print answer, which feels reasonable. We have on the bank example, credit and debit account more related to each other, and then the ones that are less related are get balance and print statement. Fair enough. There's not only one way to do it, but I think the main thing here is print statement seems mostly unrelated to the other ones. And then lock and unlock seem related to each other, and add entry and get entries seem related to each other. Cool. That seems reasonable as a diagram with the information that we have. Calculator, add, subtract, print looks like it's. I'm not sure how to interpret this diagram. Private diary, it looks like on the bottom here, lock and unlock are together, add entry and get entries are together, which looks like it shows the relatedness. That sounds good. And I think in the same way that the ones on the outside seem the least related. So I think that's probably also true. Print statement is the least related. And the same with print. Cool. So it looks like we're doing the same across the board. This last example, bank looks like print statement is the furthest away. Oh yeah, you move that slightly away more, Colin. Look at that. And a little adjustment there. Okay. Secret diary, same thing. Lock and unlock together. Add entry and get entries together, and then print is further away. Cool. Okay. Anyone came up with any randomly different versions of this? Cool. And all right. Okay. So let's do another short 5-minute exercise. Grab these lines of code, add it into an editor that you have, and I want you to extract the class off with the behavior of the one that's the least related. So in this case, everyone mentioned the print answer. So I want you to remove it and whack it in a class. All right, it'll be as simple as, no, we'll do it after. So no more than 5 minutes. Hopefully this will take 2 minutes. Open up an editor, have that code in your class, and then take this bit of behavior out and put it in another class. It's literally as simple as that, bit of encapsulation. Exercise 3, no more than 5 minutes. Refactor that method, essentially just take it out and whack it in another class. It shouldn't take you that long. So you don't need to share this one, just open up your editor, because we'll keep doing some more work in it. You should copy this code for the calculator, or even write it out yourself, and then move that method print, or whatever methods that you think would be useful to be better encapsulated into another class or classes. Usually I hear questions like, it's such a small class, why do you need to extract another class for it? And for this example, I always say we're just trying to think about the skill behind this, which is looking at the relatability of methods, trying to think about the cohesion of a class and making classes more cohesive. And we should be doing this all the time in our classes. So this is just for practice. I would still always split this up into its constituent classes as needed, even if it were just simply 3 methods. Okay, so for this example, you probably did something like this, and then you might have created another class and added this method here. That's as simple as it needed to be. Find out what class you want to call it, and then add the method there. In order to use them together, you can create your calculator. You can create your printer. And you can ask them to do some work. So you want a printer and then print the answer of calculator, add 1 and 1. Right, so now the printer is responsible for logging to the console, and the calculator is responsible for the mathematical operations.
Do you have both your classes in the same file? Or I know this is quite a small example, so I guess it's okay.
Yeah, you put them in always one class per file. When I do this, it's simply just like everything on one screen so you can see it. Cool. Any questions so far about that process that we did, taking one method out of this class and putting it into another? That's slightly trickier when we have tests involved, but this is the same process. It's the same process, all right? Okay, so the outcome is 2 cohesive classes compared to 1 less cohesive class. And we should always be striving for cohesive, highly cohesive classes. Okay, let's go on to the last exercise, what I want to give everyone a little bit of time for. I want you to not worry about tests for the moment. but take again that secret diary example and first organize it into one class. Here's a little bit more information about the requirements for those methods: lock, unlock, add entry, and get entries. And I want you to organize it in one class first. All right. Once you've managed to implement your class secret diary with those methods and it's working as expected, then I want you to think about that diagram where you put your lock and unlock together and add entries and get entries together. And I want you to think about reorganizing it into two classes, two or more, with high cohesion. All right. So what I'm looking for: open up your editor, write out your secret diary example. So you should have something like class secret diary. With a bunch of code here in one class to begin with, after you've implemented all of these methods: lock, unlock, add entry, and get entries. So you'll have a lock method, an unlock method, a add entry method, and get entry method. It might have arguments and using that. All right, so I want you to implement all of these. Looking at the information here, all in one class, and then reorganize into two or more classes. All right, fairly straightforward to make it into two classes. All right. Any questions before you start? Give me a thumbs up if that makes sense. You know what you're going to start doing. Cool.
Should we be writing tests for these methods?
I mean,
Or
really great question. I love that you asked. And in general, yes, but not for this exercise. All right. Cool. All right. Let's do some work. Half an hour. See how far we get. We'll might send it to 10:45 or 11 o'clock. And any questions, let me know. I will be on Discord. Right. Otherwise, I'll ping you on Discord when I want you to return. It will either be at 10:45 or 11 o'clock, depending on how far we get. Cool. All right. Enjoy. See you then.